So now let's do the next question. Find the inverse Laplace transform of the signal x of s is equal to 2s plus 1 by s plus 1 into s square plus 2s plus 2. Okay, so here you can see that ROC is not given, so that means you can assume that this signal is a right-sided signal. That means it is a causal signal. Okay, that means for every answer just attach a u of t, that's all. Okay, so now let us do this problem. Here given x of s is equal to 2s plus 1 by s plus 1 into, okay, so here how to factorize this equation? Okay, this equation is not factorizable directly. You cannot directly factorize this equation, right? So in that case, what do you do? How do you factorize this kind of an equation? Let me just show you a rough work. Okay, how to factorize this equation. Okay, let me write this equation over here: s square plus 2s plus 2. Okay, so how to factorize this equation? Okay, the main trick to factorize this is, first you look at the first two terms. Okay, look at the first two terms, s square plus 2s. Look at the first two terms and see which term you can add along with this to make this equation factorizable. That is s square plus 2s plus, what should I add along with this so that this equation becomes factorizable? Okay, we all know that s square, if I write s square plus 2s plus 1, then this is nothing but s plus 1 the whole square, right? S square plus 2s plus 1 is nothing but s plus 1 the whole square. So from this, that means that I can make this equation factorizable if I can put a 1 inside it, right? If I can be able to create a 1 inside, then I can make this equation into s plus 1 the whole square. That means this can be written as s square plus 2s plus 1 plus 1. Okay, and this is nothing but s plus 1 the whole square plus 1, or s plus 1 the whole square plus 1 square. You see, this is how we factorize it. So an equation which you cannot factorize, if you cannot factorize any equation directly, all you need to do is simply look at the first two terms, s square plus 2s, and then you see how can I factorize this using s square plus 2s. So I know that if I put s square plus 2s plus 1, then I am getting this equation, s plus 1 the whole square. So what I do is I add plus 1, in that case I minus 1 from here, and then I will get s square plus 2s plus 1 plus 1. You see, this is nothing but s square plus 2s plus 2. Alright, so I separate this so that I can get s plus 1 the whole square. So I will get s plus 1 the whole square plus 1. Okay, so now what should we do? Now after this, what should we do? So this is nothing but a square plus b square. Okay, we can factorize a square plus b square also. A square plus b square is nothing but a plus jb into a minus jb, complex numbers. You can make this equation into two complex numbers, right? So in the same way, I can say this is as s plus 1 the whole square plus 1 square is nothing but s plus 1 plus j and s plus 1 minus j. Okay, this is how you are able to factorize. You don't have to write these steps in the exam. In the exam, you don't have to write these steps. This step is just to show you how should I factorize the second term. Okay, so how should I factorize it? Look at the first two terms and with the use of these first two terms, try to make a factorizable equation, and then after that you include this term along with it. So this will become in this format, and then this will become in this format. So this is your factors. That is, now I'm going to put this over here. So this is nothing but s plus 1 plus j and s plus 1 minus j. See, so now this problem is nothing but a problem with three distinct poles. Okay, so that means I can write as x of s as x of s is equal to a by s plus 1 plus b by s plus 1 plus j plus c by s plus 1 minus j. Okay, so now I'm going to find the value of a, and here in a the denominator is s plus 1, so I'm going to remove s plus 1 from this equation. I'm going to remove s plus 1 from this equation. So what will I get? I'll get 2s plus 1 by s square plus 2s plus 2. Okay, here s plus 1 is equal to 0, so the value of s must be minus 1. So s is equal to minus 1. So substitute s is equal to minus 1 over here to find the value of a. So here minus 2 plus 1 is minus 1 by, here it is minus 1 square is 1 minus 2 plus 2, that is 1 plus 2 is 3, 3 minus 2 is 1, so the answer is minus 1. The value of a is minus 1. Okay, this is how we find. Next we find the value of b. So in b the denominator of b is s plus 1 plus j, so remove s plus 1 plus j from here and write the remaining question. That is 2s plus 1 the whole divided by s plus 1 into s plus 1 minus j. Okay, s plus 1 plus j is equal to 0, so you will get s is equal to minus 1 minus j. So substitute here s is equal to minus 1 minus j. Okay, so what you will get? So if I put s over here, if I replace s with minus 1 minus j, what will I get over here? I will get minus 2 minus 2j plus 1 the whole divided by here s plus 1, and yes, minus 1 minus j plus 1, minus 1 minus j plus 1, so minus 1 plus 1 gets cancelled, you will get minus j. Here you will get minus j, and here if I substitute minus 1 minus j plus 1 minus j, then that minus 1 and plus 1 gets cancelled, so I will get minus 2j. Okay, this is nothing but, here minus 2 plus 1 is minus 1, so I get minus 1 minus 2j by, here minus of minus becomes plus, j into j is minus, and so you will get minus 2. In other words, the value of b is nothing but 1 plus 2j by 2, right? Or in other words, it is 1 by 2 plus j, 1 by 2 plus j, right? Or in other words, instead of writing 1 by 2 plus j every time, I can write 0.5 plus j. Okay, so that will be very easy, 0.5 plus j. So this is the value of b. The value of b is 0.5 plus j. Now to find the value of c, you don't have to apply the same step. You don't have to apply the same calculation to find the value of c. Okay, to find the value of c, since if you see over here, the denominator over here are two complex poles, right? Here s plus 1 plus j, and this here it is s plus 1 minus j. So these two poles are conjugate of each other. In such a case, in order to find the coefficients are also conjugate of each other. That means you don't have to find the value of c using this method. You can simply write that c is nothing but the conjugate of b, or in other words, the value of c is nothing but 0.5 minus j. See, that's the advantage of using this method. You don't have to find the value of this coefficient. Simply you can just make this conjugate of the other coefficient. That's all. Okay, so in other words, I am getting x of s as x of s is equal to, the value of a is minus 1, so I will write here minus 1 by s plus 1 plus the value of b is 0.5 plus j, so it will be 0.5 plus j by s plus 1 plus j, and the value of c is 0.5 minus j, so 0.5 minus j by s plus 1 minus j. Okay, this is the value of x of s. Now what I'm going to do is I'm going to apply by inverse to each and every of these terms. Okay, so that means x of s is nothing but the Laplace inverse, x of s is nothing but Laplace of x of t. That means okay, x of t. This is what I meant is x of t is nothing but the Laplace inverse of x of s, right? Or in other words, it is the Laplace inverse of minus 1 by s plus 1 plus 0.5 plus j by s plus 1 plus j plus 0.5 minus j by s plus 1 minus j, right? Or in other words, if I'm apply Laplace inverse to each and individual terms, I will get minus Laplace inverse of 1 by s plus 1 plus, this is 0.5 plus j is constant, 0.5 plus j, Laplace inverse of 1 by s plus 1 plus j plus, next is 0.5 minus j, Laplace inverse of 1 by s plus 1 minus j. Okay, this, so we know what is Laplace inverse of 1 by s plus 1. It is e raised to minus t u of t, right? So this becomes minus e raised to minus t u of t plus 0.5 plus j into the Laplace inverse of this is 1 by s plus a, right? The Laplace inverse of 1 by s plus a is e raised to minus at. So therefore the Laplace inverse of this is e raised to minus 1 minus j into t u of t. Okay, that's Laplace. Plus, now the Laplace inverse of this, right? That is 0.5 minus j. Laplace inverse of this is similarly, it is e raised to, this becomes minus 1 plus j t u of t. This is the equation. Okay, so this is the answer. What you can do is you can now change this answer. You can remodify it and make it even more simpler, right? Because the reason is we know that e raised to j theta plus e raised to minus j theta by 2 is equal to cos theta, right? We know that. And also we also know that e raised to j theta minus e raised to minus j theta by 2j is nothing but sin theta. Okay, so I can make this equation in these two formats. Okay, then I can simplify my answer, right? So in that case, this will become, I can take this 0.5 as common, right? I can take this 0.5 and e raised to minus 1 common. So it will be very easy for me. E raised to minus t u of t plus, so if I take this common, it will become 0.5, right? 0.5 into e raised to minus 1 e raised to minus 1 into e raised to minus 1 t, right? E raised to minus t into e raised to minus j t u of t plus j into e raised to minus t into e raised to minus j t u of t. Okay, and likewise over here also, plus here also 0.5 into e raised to minus t into e raised to minus t into e raised to plus jt, right? U of t minus j into e raised to minus t into e raised to j t u of t. Okay, so this is, so now I can take e raised to minus t common, right? And then I can join both of them. I can take e raised to minus t common. So it will become e raised to minus t u of t plus 0.5 e raised to minus t. So e raised to minus t, 0.5 e raised to minus t is over here, and 0.5 e raised to minus t is over here. So if I combine both of them, I will get e raised to j t u of t plus e raised to minus j t u of t. I can take u of t also common out. Okay. Likewise, that is one equation over here. So I can combine other, and similarly over here also, plus I can take j also common. If I take j common plus j common, then I can write over here as e raised to minus j e raised to minus t, right? J e raised to minus t. J e raised to minus t common. So it will become e raised to minus j t minus e raised to j t, okay, into u of t. Okay, here also I can take u of t common, no need to write it inside the bracket. U of t. Okay, so this is nothing. So now I can get, this is nothing but minus e raised to minus t u of t plus 0.5 e raised to minus t. So what is e raised to jt plus e raised to minus jt? If you look over here, e raised to jt plus e raised to minus jt is 2 cos theta, right? 2 cos t. So this is nothing but into 2 cos t into u of t, right? Plus now if you look over here, here j is already over here, right? J is already over here, and here also that j is also over here, right? So, and also if I take this minus outside, then this will become, let me rewrite this. So this will become minus, taking minus outside, it will be minus j e raised to minus t into, so this will become e raised to jt minus e raised to minus jt. Okay, in this format. Now this equation becomes in this format, right? Minus, and also here's a j over here also, right? So I can remove that. So in the, what I do is I multiply numerator denominator with j, so this will become plus. So that means, and multiply numerator denominator with 2j. It's much better. So it will become minus e raised to minus t u of t plus 0.5 e raised to minus t into 2 into 0.5 is 1, right? So I don't need to write that. 2 into 0.5 is 1. So e raised to minus t cos t u of t plus, so this will become, so multiplying here, j into j is minus 1, minus 1 into minus 1 becomes plus. So this will become plus 2 into e raised to minus t by e raised to jt minus e raised to minus jt by 2j. This is nothing but sin t, right? Sin t. So your answer is minus e raised to minus t u of t plus, here you will get e raised to minus t cos t into u of t plus 2 into e raised to minus t, this is sin t, right? Sin t u of t. Okay, so this is your answer. Okay, since in this question the reason I put u of t over here is because they have not mentioned whether this is a they have not mentioned the ROC, so you can assume that this signal is a right sided signal. So right sided signal means then there will be no any change in the sign, and just put an u of t in front of every term, that's all. Okay, so this is your answer.